the intermediate value theorem. This is one of the several theorems in this class that you will be required to know and understand. I'm going to use the abbreviation IVT often, so if you ever see that, this is the theorem I'm referencing. So let's read through the theorem itself. It says, if f is a continuous real-valued function defined on the interval a to b, with f of a not equaling f of b, and y is a real number between f of a and f of b, then there exists some c that's an element of the interval a to b such that f of c equals y. So there's a lot going on here, so let's break down what this thing's even talking about. So let's highlight a few things. The first thing, it's continuous. All right, this is big, okay? If you know a function's continuous, you can utilize this intermediate value theorem to your advantage in a lot of problems. So make sure that we understand that for this to work, the function has to be continuous. Now, from here, I think it's best to draw out a picture and try to understand what this theorem's telling us. So it says it's a real valued function defined on the interval a to b. So let's just draw a continuous function. We'll draw a coordinate plane here. And let's just draw a function that goes from a to b. We can choose a and b wherever we want. Let's choose this to be a. We'll call this b. We're going to draw a continuous function along that interval. So it could be whatever we want, but let's say we go something like that maybe. Okay? Actually, let's make this a little more, not as flat. Okay, so there's our function. It's continuous from a to b. And it says f of a cannot equal f of b. So where's f of a and f of b? Well, if we track down the output at a and the output at b, that will give us the location of f of a and f of b. So here's f of a, and here's f of b. So we can see that they're not equal to each other. They say there's a y between f of a and f of b. So at some point between here and here, there's some number y. Okay, so we can choose any point along that interval to place y. So let's do that. Let me just fill this in again. So let's choose y to be somewhere. Let's say this is y. It says there exists some c that's between a and b such that f of c equals y. So there's some number c between here that if I plug in c, I'll get y. Now, how can we figure out where c is? Well, you can backtrack from y to figure out where that c location is. So if we backtrack, we can see that that point c would produce the output of y. So as we can see, this equals f of c. Right? So y doesn't have to be in the location we chose, as long as it's anywhere between f of a and f of b. We could have chose y, let's call that y1 and c1. We could have called this y2. That's a location for possibility for y. And if we backtrack, we still find a point that's between a and b that would produce that output. So very simply put, to understand this theorem, if the function's continuous, which is a necessary condition, then all y values between f of a and f of b exist as a result of plugging in, wait, what? Why did I change black? So as a result of plugging in values between A and B. Okay? That is the intermediate value theorem. Now, there is an extension to that that is a useful consideration. So let's write the extension to the IVT. It says if f is continuous from A to B, and f of A is less than 0, and f of B is greater than 0, or vice versa, so that could be switched, then f of x equals 0 for some value between A and B. So what does that mean? We draw another picture. We have our coordinate plane. This time they're telling us that we have a continuous function from A to B where f of A is less than 0, so the output for A has to be below the x-axis. We'll say it's down here. The one for B is above the x-axis because it's greater than 0. And again, we could have those flip. This isn't a necessary condition to have it like that. But one's above and one's below. If I draw a continuous function from one point to the other, I have to pass over the x-axis. Guaranteed that there's a value between A and B. In this case, it would be this point right here, where f of whatever that point is, we'll call it C, equals 0. Okay, there's no way that I can connect this dot here to that point there without crossing over the x-axis. So that's an extension of the intermediate value theorem. It says that if we have an output of a function that's negative, and then we have another output of a function that's positive, then by the intermediate value theorem, f of the function had to have equaled 0 at some point between those two outputs. Okay, so if you know one output is negative, here's our f of A, and you know another one's positive, then you know at some point between those two outputs, f of x had to have equaled 0 if this function was continuous. Now, if it's not continuous, then that condition doesn't necessarily apply. But if we are told it's continuous, we know that function equals 0 at some point. And it could be more than once, but we're guaranteed at least once. Okay, so equals 0 at least once. And to get used to the intermediate value theorem, we'll do plenty of examples, but that is its definition, or the theorem itself, I should say, and an explanation for it.